Hello friends. So this is again a Harvard physics problem, and this problem is called leaving the hemisphere. So problem says a point particle of mass small m sits at rest on top of a frictionless hemisphere of mass m. So here I have a point mass m, a small m, and this sits over a hemisphere of mass capital M, and which rests on a frictionless table as shown in this figure. So here I have a frictionless table. So this is a frictionless table on which this hemisphere is basically resting. The particle is given a tiny kick and slide down the hemisphere. So we have given a small kick to this mass m, and this mass m is basically trying to move in the downward direction. So question says, at what angle theta measured from the top of the hemisphere does the particle loses the contact with the hemisphere? So we have to find angle at which this small mass m will lose the contact with the hemisphere. Now we have to assume, so in answering this question for m is not equals to m, that is small m is not equals to capital M, it is sufficient for you to produce an equation that theta must satisfy. It will be a cubic equation. So we have to simply find an equation, we don't have to solve, and this equation will be a cubic equation. However, for the spherical case m is equals to m, small is equals to capital M, the equation can be solved without too much difficulty. Find the angle in this case. So for one case you have to solve this equation, that is when both masses are equal. So let us try to see how we can solve this problem. So after a certain point of time, what will happen? This mass, let's say this mass will reach here. So this mass has reached here. And let's say this angle is theta. So we can have, so this is the vertical line that we have. And then from here, this angle is theta. So let's say this angle is theta. So now I know this angle is theta. So let us find what are the forces and what are the velocity that we have. So let us assume the velocity of this mass, a small mass, is m, and this will be in tangential direction. So u is the velocity of a small mass. Velocity of m, and this is with respect to a sphere, with respect to hemisphere. So this mass is moving with a speed u, but this u is with respect to the hemisphere. And the hemisphere, let's say this itself is moving in this direction with velocity v. So v is the velocity of hemisphere. So v is the velocity of hemisphere. Now we can consider this direction as a positive direction. So this is my x-axis, positive direction. Now if you see, this velocity will have two components. One component will come in this direction. So this is u. So let's first find out what is this angle. So this angle is theta, then this angle will also be theta. And then if you extend this further, and then if you put a line here, then this angle is also theta. So this will be, so this, since this is u, so in this direction you will have u sine theta. No, u cos theta. So this is your u cos theta. So velocity of u in this direction is u cos theta, and in this direction we will have u sine theta. Now how will you solve this problem? So first thing is, there is no friction. So anywhere there is no friction. How many unknowns we have? We have unknown u, we have unknown m, and we have unknown theta. So three unknowns. So we need to write three equations. First equation, we will write momentum conservation equation. because there is no friction and initially everything is at rest. So we can write total momentum is equals to 0, since initially there was no movement, there is no momentum. So we can write momentum of a small mass m. So m times, what is the velocity of a small mass? In the x direction, so we are writing momentum equation in the x direction. So velocity of this mass, a small mass, is u cos theta. So this is u cos theta minus, because this is with respect to the hemisphere, and hemisphere itself is moving in this direction with a speed v. So this is minus v. So this is the momentum of a small mass m in the x direction. And for big mass, that is for hemisphere, this is minus mv, because this is in the negative direction of x-axis. Initially total momentum was 0. So from here we can find what is the value of, or what is the relationship between m and u and v. So we can write mu cos theta is equals to m plus m times v. So this is capital V. So from here I can say V is nothing but m by m plus m u cos theta. So this is the relationship between V and u. So we have one equation. And the second equation we can find using energy conservation. Now what is this length? So let us say here we have this length is r. So we know this length is r because the hemisphere, so this length is r. Now if you draw this line, so this length is how much? So this length will be r minus r cos theta. You can verify yourself. This length will be r cos theta. So from here to here, this length will be, so this length will be r cos theta. So this length, so let me write it here. So this is r cos theta. R cos theta. So this length is how much? So this is a small length. So this length is how much? This length will be r minus r cos theta. So if I apply energy conservation, so there is a loss in potential energy. How much loss? This is r minus r cos theta, that is the loss in potential energy, times mg. So we can write energy conservation. So this is from energy conservation. So if I apply energy conservation, we will have loss in potential energy, that is mgr 1 minus cos theta. So this is the loss in potential energy, is equals to gain in kinetic energy. So for a small mass, half times m. And what is the velocity? So velocity has two components. So vx square plus vy square, we can write half mv square, and v is nothing but vx square u cos theta minus v whole square. This is vx plus vy is how much? U sin theta whole square. This is the small mass, and the kinetic energy of big mass is half mv square. So let us simplify this. So we can rewrite. So let's write this term this side. So we can write half m, and this will be, so if you simplify this term, so we will have u square cos square theta plus v square minus 2uv cos theta, and this term will be u square sin square theta plus half mv square is equals to mgr 1 minus cos theta. Now let us further simplify. So we will have half m, and this term that is u square cos square theta plus u square sin square theta. This will be simply u square, and this is v square minus 2uv cos theta plus half mv square is equals to mgr 1 minus cos theta. So we can rewrite this is half m u square, and there is a v square and there is also a v square. So what we can do is we can write half, and this will be m plus m v square, and this term will be there. So minus 2 cancels out, so we will have m u v cos theta is equals to mgr 1 minus cos theta. So this is my second equation. So we have two equations. We need one more equation. So from where I will get the second equation, third equation. So to find the third equation, what we will do is we will consider the motion, because this particle, the small mass m, is moving in a circle. So we'll write equation of motion. So what are the forces that is acting? So on this particle, a vertical force mg is acting, and normal reaction is acting in this direction, and this angle is theta. So this angle is also theta. So in this direction we will have mg cos theta, and in this direction the component of this force will be mg sin theta. And this side we will have mg cos theta. So let us write equation of motion, because this is moving in a circle. So total force towards the center. So what are the force towards the center? Mg cos theta minus n, and this is equals to mv square by r. And what is the velocity in this case? Mv square, because this velocity is with respect to the a sphere, because this is moving in a circle with respect to a sphere. That's why here we have considered u. So this is the velocity with respect to the sphere. Now at the time when this mass is just going to lose the contact, at that point of time we will have normal reaction is equals to 0. So from here I can say mg cos theta is equals to mu square by r, or u square is equals to rg cos theta. So this is my third equation. Now using these three equations, we can solve for uv as well as for theta. So let us try to solve this. So if I plug this, and that is this one u square, and we also calculated this earlier. So this one v. So what we will do is we will take this v value, that is here, this v value, and then u value. So from 1 and 3 we will plug in equation 2. So from 1 and 3. So from 1 and 3 in equation 2. So if you plug this, you will have half m rg cos theta. You see what you have? You have half mu square, and u square is nothing but rg cos theta, plus half a small m plus capital M v square. And v square was what? We already calculated v square. You see here, v is m by m plus m u cos theta. So this is m by m plus m u cos theta, and a square of this term, minus we have mu v cos theta. So this is mu v cos theta, and this is equals to mgr 1 minus cos theta. So this is equals to mgr 1 minus cos theta. Now you have to solve for u and v. So let us say if I plug the value of v here also, then we can calculate, and u also, then we can basically calculate theta. So here I will have half m rg cos theta plus half m plus m. So this will simply become half m square, and 1m plus m will be cancelled, and then you will have u square cos square theta, and minus this term will be muv cos theta is equals to mgr 1 minus cos theta. So in the next line we can have mrg cos theta plus half m square divided by m plus m, and we can plug the value of u. U is what? U square is rg cos theta. So this will be rg cos theta, and we already have one cos theta, so this will basically become cos q theta. So let us say this is rg cos theta, and let us skip this for the time being, cos square theta minus and muv. But what is v? V is, you remember, v is this term, m divided by m plus m u cos theta. So this is my v, and this is cos theta is equals to mgr 1 minus cos theta. Let us further simplify this term. So we will have half mrg cos theta plus half m square m plus m, and this will be rg cos q theta minus this will be m square divided by m plus m, and this is u square cos square theta, and u square is nothing but u square is rg cos theta. So if you remember, u square is rg cos theta, and then we have cos square theta also, cos square theta, and this is equals to mgr 1 minus cos theta. So now you see this term and this term are same. Only thing, there is a minus sign. These two terms are same. So we can simplify half mrg cos theta, and this is minus because half, this term is half and this term is full, and everything is same. Here also you have cos q theta, here also you have cos q theta. So this will be minus half m square divided by m plus m rg cos q theta. This is equals to mgr 1 minus cos theta. Now let us divide by mgr throughout. If I divide by mgr, so I will have cos theta by 2 minus, and since I have already divided by mgr, so I will have minus half m cos q theta divided by m plus m, and then here I will have 1 minus cos theta. So, and we can multiply it by 2 both sides. So we will have cos theta minus m divided by m plus m cos q theta is equals to 2 into 1 minus cos theta. We can further simplify. So we can multiply m plus m and cos theta minus m cos q theta is equals to 2 times m plus m into 1 minus cos theta. If I divide by a small m throughout, we will have 1 plus m by m cos theta minus cos q theta. This is equals to 2 times 1 plus m by m, 1 minus cos theta. So let us assume we are defining a term. So let's say capital M by a small m is equals to r. So remember, we are taking capital M by a small m is equals to r, not a small m by capital M. You can also do that. So in this case, we will have 1 plus r cos theta minus cos q theta is equals to 2 into 1 plus r into 1 minus cos theta. So this is the expression that we will have. So you can write minus cos q theta, and let's take plus 1 plus r cos theta, and I can take this term this side, so minus 2 into 1 plus r into 1 minus cos theta is equals to 0, or we can have cos q theta and then 1 plus r. Let's take cos theta common. So what we have done, first let's multiply by negative sign. So you will have negative here, this will become negative and this will become positive. So we have changed the sign. Now let us take cos theta common. So here I will have minus 1 plus r, and here I will have minus 2 times 1 plus r, and then plus 2 into 1 plus r is equals to 0. So here I can say cos q theta plus, and this will be minus 3 times. So this is minus 3 times 1 plus r into cos theta plus 2 times 1 plus r is equals to 0. So this is the expression that we are looking for. So this expression will give me value of cos theta. And this is a cubic equation. You can see here, this is a cubic equation. Now in a special case, when m is equals to m, a small m is equals to capital M, in that case r is equals to 1. So if r is equals to 1, this equation becomes cos q theta minus 3 into 2, 6 cos theta plus 4 is equals to 0. Now this, we have to find the solution for this. So you see, 2 is a trivial solution. So 2q8 and 6 into 2, 12, and 4 in this is 4. So 8 plus 4, 12, minus 12 is equals to 0. So cos theta is equals to 2 is a solution. So basically we can further factorize it, cos theta minus 2, and the second factor will be cos squared theta plus 2 cos theta minus 2 is equals to 0. Now this is again a quadratic equation. So we can find the solution. So this is cos theta is equals to 2 is not a possible solution, not possible. So this is not possible. And if you solve this quadratic equation using minus b plus minus b square minus 4ac by twice a, you will have two roots, and these roots will be minus 1 plus minus root 3. Negative will not be possible because that is greater than 1. So this solution is again not possible. So this solution is also not possible. Another solution that is left, that is root 3 minus 1. So this is only possible solution. So we will have cos theta is equals to root 3 minus 1, and this gives theta is equals to 42.9 degree. So if both masses are having equal mass, in that case the particle will leave the hemisphere around 43 degree of angle from the vertical. I hope you enjoyed this video. If you enjoy, please like and share and subscribe, and I will see you in the next video. Thank you so much.